Welcome to Why Where Matters. My name is Paul E. Zieske, and this is a place where we tackle the complex world of location-based services by open sourcing a concept we call enterprise traffic control. So today we want to go through a high-level overview of what enterprise traffic control is and the concepts that we're using to build it. These are existing computer science, engineering, and operational concepts that are out there improving themselves. And a lot of what we're doing here is a packaging exercise. So why do we use these concepts? Well, that's because a lot of the work has been done for us. One of the things you'll learn about me is I love slogans and alliteration, and this will be maybe our first Why Where Matters slogan, and that is, we aren't boiling the ocean, we're fixing the motion. Enterprise traffic control is modeled after aviation and air traffic control because of history of efficiency, reliability, and safety, and most people are familiar with that. Even in healthcare, they've gone so far as to use some of what you see in air traffic control to create what they call HRO, which is highly reliable organization. And situational awareness is at its core. When you just look at that picture of the control tower, you have windows so that you can see the ground. There's screens in there. There are all kinds of real-time information that's coming in. There's even a radar sensor in that ball, that sphere that you see on the top. And even below that, in this very picture, is a traffic control center, right? And so there's all kinds of radar screens that are coming in there. There's communications in a language that people are familiar with aviation, understand well. And when you hear pilots talking to the controllers, often it sounds like a different language. But that language is well understood by everyone. It's very synchronous, and there's predictability around that. Air traffic control and aviation have a heavy reliance on automation. There's airplanes that can fly autonomously, we know about those. Then airplanes that we fly in, the airliners that we fly in, can navigate and land automatically. We've all heard of autopilot, and there's collision avoidance systems and other systems that are part of that automation. The other thing is there's a heavy reliance on simulation. So we've seen flight simulators, but there's also simulators that controllers use in order to see airplanes moving around and to control different situations that come in. And that's for the training. But even so, for studies, they can run these simulations and see how things are operating in real time. All these pieces are the kind of things that we want to see moved into and out of the air traffic control environment into what we're calling enterprise traffic control. So we're going to start out with a one-sentence definition, and anytime you encapsulate a concept like this into a single sentence, it's going to involve some sort of abstraction. But we aren't avoiding abstraction at all. As a matter of fact, we want to create layers of abstraction that become very important, because those are going to allow us to form what's called an ontology. And that ontology are terms in the relationships between those terms. And that may sound a bit formal, but it becomes important in a world where eventually we want to establish this domain language under this ontology so that things like AI can understand it. In this world of AI, things have to be built a certain way in order for you to get the most out of it. And that's a starting point, is this idea of ontology. We'll start working through this definition. First off, the definition is enterprise traffic controls using situational awareness and automation to optimize mobile workflows across the enterprise. Starting out, let's talk about the mobile workflows. Those involve some sort of motion. Now, that motion could be people or property. It could be a large traverse across the hospital, or it could be just moving a medication through the different compounding processes when you're in the inpatient pharmacy, something like that. Situational awareness comes from communications and the digital twin. I bring up the communications because you have asynchronous and you have synchronous communications. We think of synchronous communications as maybe voice communications. You can picture the air traffic control tower where pilots are talking to the controllers, but there's also some asynchronous communication where maybe messages are being passed through a pneumatic tube system between the top and the bottom of the control tower. Those are the kind of things that go on. The digital twin is our home for automation, and we'll do another definition. It's a virtual representation of a physical object, another short one-sentence definition that's abstract, and we'll start breaking that down. So the representation of the physical object is going to be in these digital maps. So these are high fidelity geo-reference maps that it can establish the shape, that 3D building. In order for us to get to a virtual representation, we need to involve sensors so that we can make the workplace aware. It's not enough just to be able to represent that object digitally. It needs to be virtual. So that's the human side of this. And we also use automation to remove some of the human effort. We're going to get to the point where we're going to start to use the word automation as a noun. These are going to be things, right? We're going to create automations. And when we connect those automations together, we're going to call that orchestration. And once we've orchestrated things, we're now into this last piece of this definition where we're optimizing mobile workflows across the enterprise. So you can see how this fits together. There's an ontology that we're building. So we're going to keep breaking this down. We'll start with mobile workflows. So mobile workflows obviously involve some sort of motion. They divide into a task ontology. Those ontologies that we were talking about before, these can be nested, and those layers of abstractions can fit together, and it's perfectly fine, and that's exactly the way we want to see it work. The tasks that are involved in that ontology contain events, and a lot of what we do in the automation side is going to be wrapped around these events. The workflow can be divided into nominal and anomalous, and we can't ignore the anomalies in favor of trying to construct that logical flow that we have on the nominal side. We have to look at both pieces, because what we want to do if we want to get a good outcome is to make sure we're structuring it to be able to detect the anomalies as much as the nominal. You can see that obviously in what you see in air traffic control. And then we have to recognize there's deterministic and stochastic parts of these processes. So you have the predictable side on the deterministic, and then the stochastic or random side. And that could be patients arriving in a clinic in some way, especially in the ER. Those are random. You don't know that exactly when people are coming in. The automation side can be modeled as what we call a rational agent. This is where we're starting to tend to that structure that's going to allow us to be able to build AI into this, is that we want to structure it as a rational agent. Underneath that rational agent, we're going to talk about something called the environment, and that environment can include people, property, and places. So we want to divide this further in that environment. And then the workflows, the way that we're going to structure this, are aligned with departments. So we want to have a way to be able to package these workflows logically so that we can eventually get to this organizational orchestration, right? So the workflows typically are going to align with departments. So we started by looking at the mobile workflows and giving a bit of a definition and a breakdown of those, because it's the situational awareness and automation that we're going to use to optimize those workflows. So we want to dig into that now. And what you see here is we have them separated, and that's only starting out in a world where we start to evolve this and there becomes some maturity around enterprise traffic control. Those kind of things start to blend together. Starting out on the situational awareness, there's this idea of real-time information, and then there's this time diminish value of information that you get around real time. And it becomes very important to recognize that, because when you have certain pieces of real time information, they only become valuable if you have the capability to react to them in real time. So that needs to be recognized when you're building the operational changes around the capabilities that you create with the situational awareness. So it's people more on the situational awareness side that benefit, and then on the automation side, you're automating to remove some of the human work that's being done. And for automation, and just touching on that before we get to it, automation doesn't necessarily mean removing all the human work. It could be just a portion. It involves, on the situational side, involves people. And those are defined as actors. And the reason why we call them out as actors is because that fits in with our ontology as we get into this idea of rational agents and the digital twin. And they need to, like I said, need to be processed in real time. The situation is the state of the environment. On the situational side, we recognize that in the humans through the state that's described by human perception and context. So that's that humans are recognizing the state and reacting to it. On the automation side, we need technology that can be able to do that same thing. So you have machines doing the work. You have that some or all of the work. It uses the digital twin. That's how we're modeling this. That's modeled under the idea of a rational agent. And then there's this concept called P's that we're going to work through, PEAS. And then the P part is performance measures, and that determines the outcome. And the action is performed in the environment, and the environment is something that we're going to define with the 3 Ps. The actuators perform an action that can affect the state of the environment. And then the sensors involve this thing called percepts, so they can perceive the environment. Like on the human side, it may be human senses, it may be the eyes, the hearing, all those kind of things. On the automation side, we have technology or sensors that allows us to be able to create those percepts. Okay, let's dig deeper into this idea of the digital twin. And again, the definition is a virtual representation of a physical object. That abstract definition, we're going to break that down. So the physical object is a building, but it can be indoors or outdoors as well. You could have an outdoor workflow that needs that component of it. But starting out, we'll talk about the building. And it's represented with IMDF, which is the Indoor Mapping Data Format. I'm picking one. There could be others. This is what they call OGC, or Open Geospatial Consortium version. So we want to use standard. So for this, we're going to use IMDF. It's enhanced with GIS, so Geographic Information Services. And that really gets us into this idea of geospatial processing, which is going to become very important to what we're doing. We use sensors to create awareness, and that becomes important for this virtual component of the representation of the physical object. It includes actors. That isn't readily apparent when you think of the digital twin, but it definitely includes the people that are operating in that environment. It provides the environment for automation, and you want that to be able to be described digitally. We use automation to create the efficiency that we want to get out of it, and we also have this context and percepts for the situational awareness, because even within the digital twin, there's still a human and a machine component to it. I said at the beginning that I like these silly slogans and alliteration, but those really are memory tools, and they definitely help us move forward and make this repeatable. That's the biggest thing that I think that we get out of some of the structure that I'm trying to add into this right now for you. So let's start out with the 3Ps. And the 3Ps describe the components of the digital twin, and it's going to give us a way to start to categorize things, right? So for the digital twin, we have people, property, and places. Those are the 3Ps. So initially, when we're looking over a particular workflow or something that we're trying to automate, we're going to look at who are the people and what are the people that are involved and what kind of property. And that isn't just medical equipment. It could be supplies. It could be any kind of thing that you need in order to do your job. It really is that idea of things. And then places, of course, is where is this work being done? It doesn't necessarily, like I said, need to be the entire building. It could be a single room, or it could be outside the building as well, right? So but we need to know that when we're constructing these automations and packaging them in the digital twin. So then we get on to P's. P's, again, is the performance measures, the environment, actuators, and sensors. And I'm going to break that down in a minute. And then we have the 4Ps, which when we get to the sensors, we want to have a catalog of all of the percepts that we can use in order to build a workflow. It isn't enough just to know that we have a location sensor. We need to know all the capabilities of that location sensor. And typically, a location sensor has capabilities that aren't readily apparent by perhaps the vendor. Like let's say a real-time locator system can provide the position of a particular tag that's affixed to a piece of medical equipment, but these other options for location sensing are available to us in these percepts, right? So it might not be just position. It may be proximity, presence, and possession that are all parts of what we can do with these sensors, but we need to examine those and catalog those as a part of this process. So that's why that's in there. So we talked about the 3Ps, how that aligns with the digital twin. It allows us to categorize all the elements that are in the digital twin, but we need to dig a little bit deeper, and we're going to use rational agents to model more of what we're doing in the digital twin. Now, a rational agent is described here, always makes decisions to get the optimal outcome that's reflected in the environment, okay? So that can be a human or a machine involved, right? So obviously when we're making decisions with a machine, it's some sort of smart or intelligent component to that. But also we can have humans that are operating as the decision makers in these workflows, okay? But we want to model them holistically. So we want to pull it all into one structure so that we can examine it and see what components are best for automation and what are best for situational awareness and having the human involved. So the performance measures measure the rational agent and the ability for it to be able to determine the optimal outcome. That's rather straightforward. We need some sort of measurement so that we can determine what that optimal outcome is. And so for the environment, we need all the information to be able to describe the surroundings and the state of the environment, because the new state of the environment is how we're going to see that optimal outcome. So we have to have some way to be able to see what the state of the environment is, and it's also packaged in that environment, okay? And then for actuators, actuators are what actually performs the action to inflict the change in state that maps back to that performance measure that would be tending toward that positive outcome. Well, that was kind of a mouthful, but it's the actions that are being done by the actuator. And in some instances, that could be human, and in some instances, machine. And then sensors on the last part are what can perceive the state of the environment. So we need sensors to be able to understand what the state is, just like we need senses. So we can model the senses of a human in here just as much as we can a machine sensor, but we want to make sure that we're cataloging those under sensors. We talked about the 3Ps and how that helps us catalog all the elements of the digital twin. We talked about PEAS and how that describes the rational agent and what we're doing with rational agency. And now we're going to talk about 4Ps and sensors. Now remember, there's senses human, and then there's the senses of these electronic devices. This list is mainly around location. And so typically when somebody thinks about location, they think about position. They think about where something located, maybe in a coordinate system in 3 space. But there's more to it with these sensors that we can use these kind of technologies for. So we need to look at each one of these and catalog it for its capabilities. And again, this is describing more the percepts that you get out of this location technology than it is the sensors themselves. So we'll start with position. Position is the location of an entity in some coordinate system, and that entity has an identity. Sorry for the tongue twister, but what we want is to be able to find something in a coordinate system. Again, that coordinate system can be in 3 space, but we need to know what thing that is. If it's an IV pump, we need to know which IV pump, okay? Then when we get to proximity, we have a source and a target, and we know the location of the source. And so it really starts with position, but then you use that position in order to infer the location of something else, which is that target. So again, I'll just read through it so we're clear. Proximity has a source and a target. We have the position of the source, and we might get a range to the target. We might not need the range. In many cases, we do need the range if we're going to perform some calculations on it, and maybe even probabilistically determine, how something relates to the source. So with presence tells us that some entity is in a space. We know what the entity is. So if it's human, we know it's a human, but what we don't know is the identity of that. And that can become very valuable when you talk about things like an inference engine or trying to combine and fuse contextual data. So it is something we want to consider when we're working with these location technologies. Last thing is possession. And possession is we've established a persistent proximity of an entity to another entity. So we know that these two things are together. And what that really is for, in short, is custody or chain of custody. So now we have these 4 Ps, and we can use these as a part of our recipe to build these workflows. So let's take the time here to do a little bit of a recap. So we started out and we looked at these computer science concepts. They form the elements of our ontology. Some of these are computer science, some of these are operational concepts. And we looked at the digital twin, and we saw the digital twin fits in under this idea of Industry 4.0. We talked about the P's model, and that fits in AI and robotics, but it still fits into this packaging exercise we're doing under enterprise traffic control. The 4 Ps, that's some alliteration that we use in order to understand more about what the sensors can do around location and the percepts. Now let's talk about the distributed context-aware system, and that's another concept. We could have a context-aware system, and when we add in distributed sensors or even additional external contextual information, it all of a sudden becomes a distributed system, and those are incrementally more complex, but also incrementally more powerful. In order to process that information, we go through these 5 steps. So the first one is acquisition. So that's pulling the data in. It may be cleaning the data. It may be massaging the data in a certain way in order to get it ready for the next step, which is modeling. And modeling is going to put the data in a format that it can be used and processed in the next phase, which is fusion. And fusion can take different kinds of information that may be high level or low level and mash them together and get in order to get more powerful insight. So maybe the example I will give here is that if you had positional information about 2 people in a room, and then you have presence information that there's actually 4 humans in the room, you have an insight there that there's 2 additional entities being humans that are in the room that need to be considered for whatever workflow you're working with. And then having all that information gets you to the next phase, which is the reasoning phase. And that can be something as simple as a condition action sequence, or it can be something as complex as an AI. So we have what we call smart, and then we have intelligent, and that fits into this idea of reasoning. And again, all these things to a degree can be processed by humans. We can model it that way, but for this case, mostly we're talking about machines. Lastly, we have adaptation. And adaptation is very interesting, especially in a distributed system, because a distributed system relies on something that you call nodes. So a node is just something that's external to the system, somewhere that's necessary to process and pull things into this to the central system. Sometimes those nodes are missing or are removed, and the information has to adapt to that. So you have an adaptation. Sometimes it'll maybe even be called self-healing. So there's a lot of different things that come into adaptation. The self-healing is an example that we'll give here today. So as we take a deeper look at the process side and the organizational change side, should start out with this Bill Gates quote, and that's the first rule of any technology used in business is that automation applied to an efficient operation will magnify the efficiency. The second is automation applied to an inefficient operation will magnify the inefficiency. That's something we should keep in mind as we move forward with this discussion about process. So now we want to get a little bit away from the technology and start talking about some of the operational aspects of enterprise traffic control. And of course, we recognize that air traffic and aviation are some of what we use to inform what we're doing in enterprise traffic control. So let's look at the way this breaks down here in the slide, the phases of flight. So you have ground, terminal, and route, right? So those are an airplane that starts on the ground. There are controllers that are visualizing that aircraft on the ground. Then it takes off and it moves into the terminal control. And there's a handoff that is done between ground and terminal. And then eventually, after terminal, it gets into the route, and then the route connects you to the next terminal, and then ground, and then that all repeats. So you can see what you have in this is you have handoffs, and then with each one of these phases, there's also radar sensors that are a part of that. So that's all one closed loop flow that we look at. And it has situational awareness, it has automation, it has all the components. And then we can look at, that's the air traffic component of this. So if we look at perhaps the airlines have the gates, right? And the gates have the above the wing and the below the wing, right? So the above the wing is all the kind of hospitality components of what you see the airlines doing, and the below the wing is all of the operational things that are necessary in order to get the airplane ready to take off, right? And then there's handoffs between the gate and ground and everything. So there's always a handoff, and everything is connected. And then the air terminal itself. Then so when you're talking about the people that are trying to get on these airplanes, they're a persona that's involved in this that needs to be recognized as well. And they go through what's called the land side and the air side. So when you show up at the airport, before you get through security, you're on the land side. And then once you get through security, you're on the air side. There is kind of a handoff that goes on in there, and then you end up at the gate, and then you end up in these phases of flight, right? So you can see that there's all this modeling that can be done around this idea of aviation and air traffic. And we can do the same thing in healthcare, and we can do that around departments and the way those departments interact. These are kind of like departments. And that's a reason why I brought air traffic into this, is that we can look at these as a model of these handoffs, both for the operational and then the customer side. So we talked about creating one of these automations. We started with the 3 Ps and the digital twin all the way down to the 4 Ps and the individual sensors. But we need to look at how we're going to use an automation to optimize a mobile workflow. So there's some steps and a process involved. So we would start with a process model, and that might be a swim lane document. It should start with the as-is condition so that we can see all the elements that are involved and the steps and the decisions and everything that goes into the initial condition. Then we want to identify in there the nominal flow. And sometimes that's called happy trails. What's the pathway through that process that we would want to see in order to create the outcomes that we're looking for? Then we also need to identify the anomalies. So anything that's outside of that flow that can cause problems with the outcome. Error conditions, things that are inputs that are bad, or behaviors that can negatively influence the process model. Because what we're going to want to do later is to look at if we can monitor them. We want to monitor nominal flow, we want to monitor cues, and we want to put them into the digital twin. That could be part of the automation to create that situational awareness, even if it is the as-is condition and you haven't really removed much work from the flow. Even the monitoring can be a form of automation. We want to model the workflow with a simulation model if we can. We talked about simulation previously and how valuable it is. We have discrete event simulation, which is here's DES, and then there's another option that's called agent-based modeling. And agent-based modeling actually helps us get into some of the stochastic or random processes that can be modeled. What that allows us to do is to be able to see with real data how the process will flow. And if we can do that and we can put a change into that model based on what we have above there with the process model and being able to identify that nominal flow, then we should be able to predict the outcome with the simulated model. And then what that hopefully will allow us to do is to put in some changes that will help us challenge the status quo. What is it that we're doing now that we could possibly change to get a more positive outcome, to trend in the right direction when we're trying to create the positive influences on these performance measures that we had in the piece? Again, if we challenge the status quo, we start to update some of these processes, what we want to be able to do is adapt the organization to the new capabilities that we're going to be putting in with enterprise traffic control and some of these automations. It isn't enough with the Bill Gates quote to add the technology. We need to make sure that we're looking at the entire process to see if we're going to get the most optimized outcome that we can get. We do want to add the automations to create the efficiency, like we stated in the definition around enterprise traffic control. Also, we need to look at, talked about above, the possibility of adding context and percepts for situational awareness, not just the automation, because it could be that the situational awareness and creating more visibility into some of the things that are going on for the human will still optimize the mobile workflow, even when we haven't removed some of the effort, right? So I hope that all makes sense. And certainly in the future, we're going to run some processes through this and demonstrate how this might work. So in our definition of enterprise traffic control, we have situational awareness and automation to optimize mobile workflows. Sometimes I'll say across the enterprise, but at an enterprise level. Certainly at an enterprise level means that we're doing it above the department level. We're not just trying to create individual automations. Reason for that is what you can do is just push those bottlenecks and push those queues into another department where they're still waiting and you aren't going to get flow out of the entire system. That's why what you want to do is be able to create automations and eventually knit those together so that they can create a flow that goes end to end. So when we do that, when we look at those handoffs between the departments and we're able to eliminate those queues and to create those seamless handoffs or more effective handoffs, we are moving from what we call automation to orchestration. And we're using orchestration as a noun, just like we're using automation as a noun. And some of the things that we can see that would result from that is co-locating dispatchers, right? So if they have the ability to be able to see these individual departments and what they're doing, then if you co-locate dispatching, then you provide situational awareness, then they can create those handoffs kind of on the human side and less on the automated side and move things along and eliminate those queues. So you have the interdisciplinary resources between the different departments. These could be completely different skill sets. So patient transport has a different skill set than housekeeping, and some of these specialty services on the clinical side have completely different skill sets than some of the nursing and these other teams, but they still can be involved in a process where these things need to get handed off. And because you have these interdisciplinary resources and you've created this visibility and you now have the ability to be able to do these handoffs and remove some of these queues between all this, you can see that a vision for a command center starts to form where we can do this co-located, we can expand the types of resources that and departments that are represented in this command center, and we can provide, this 24/7 perhaps, and a kind of a 360-degree view into the operations for the things that are moving, right? And that ties back into our definition of what enterprise traffic control is. You could even envision the idea of a command center where it's not just about enterprise traffic control, it's more at a real-time healthcare level. So again, we said back in the beginning that we are not boiling the ocean, we're fixing the motion. But the ocean may be everything that goes on in the command center, and just fixing the motion is one part of that. So with enterprise traffic control and all these new real-time capabilities and visibility and situational awareness in these automations, there's going to be a lot of capabilities that are going to be added for expanding things like dispatching. Like we talked about, it may be that a particular hospital in a hospital system doesn't have dispatching, but the other does for, let's say, patient transport. Once you've created that command center structure and they have the visibility into that space, there's no reason why you couldn't offer those dispatching capabilities to an expanded geography across the hospital system. So you could expand the use of dispatching to different departments that don't even have dispatching now, right? So those are responding to work orders or stat things that come in that are immediate and need to be addressed, in real time. So again, and those kind of things do remove bottlenecks, and dispatching is a communication hub for getting work done. And a lot of times the lack of dispatching is only because of the resourcing and the lack of capabilities that they have. So one of the things that you would want to look at is, can we expand the use of dispatching to speed things up and remove bottlenecks? Once you've expanded the use of dispatching, you can consolidate the dispatching, and that really gives you the opportunity for these interdisciplinary resources to start to communicate and start to understand, because they are interdependent, how each other works, and to start visualizing what these handoffs might look like in a co-located setting. Once you've done that with the resources or with the dispatching, you could create automations that would make some of those handoffs seamless. And then that is, by definition, that, like we said, orchestration being a noun, that is the idea of orchestration. Eventually, the vision for this should be that these dispatchers are so capable that they've evolved from this idea of a dispatcher to a controller. I recently had somebody ask me a question on what that might look like, and I had somewhat of a visual, but it did make me think more about what that might be. When I think of dispatching, I think of something that is pretty straightforward, and it's a communication hub, and you are processing work through whatever, like we said, a communication. So it could be phone calls coming in, it could be some sort of asynchronous text, and you're kind of moving things around. Controllers are much more capable because they have more responsibility over the outcomes. They have much more responsibility over the anomalous parts of the flow, right? The error conditions, the defects, and they are, it's an enhanced skill set. It's requires training. It's I was even thinking about the user interfaces for some of these tools, and how when I think about radar systems and some of these air traffic control tools, as a lay person, you just don't walk in and look at that and understand how it works. I think with a lot of the dispatching tools that I've seen, they're pretty straightforward and they're not real sophisticated. But when you get into this kind of control, you want to get as many things on a single screen as you can. So what that means is that you're increasing the cognitive load that you're putting on a single screen. So you want to have people that are highly trained in order to do that. And that's what you see in this controller-based environment. And it does make things move faster, because just with the dispatching, it's kind of things are spread out. But when you have a controller, it's condensed, there's a higher cognitive load, it's more real time, and maybe it's even that those controllers are addressing more and more departments. Those are, I think, the kind of things that you might be able to do. As you do this, and as you're moving from dispatchers to controllers, then that's going to help understand the possibilities for artificial intelligence, and using intelligence in order to do the reasoning components of a lot of what we talked about in these automations and orchestrations, right? And that doesn't mean that we couldn't use AI all along, but again, as you increase the cognitive load on the humans, you can relieve them of some of that by adding an AI. And that really is the purpose of AI these days. People are much more willing to look at as a tool for suggestions and predictions and things that are going to help you cut through layers in order to get to an outcome. And then the last thing is adding robots and drones. And these are real. I mean, we've seen robots that do lots of courier services. They may be used in the labs for moving specimens around, or even in the pharmacy. They're using robots quite heavily in the pharmacy to do the courier services for moving medications around, whether they're stat or scheduled deliveries. Drones, there's still some bottlenecks through the Federal Aviation Administration to get them to be available for flights for things like labs and medications. There's a lot of companies that are looking at doing this, and something I think we're going to see in the future once those hurdles with the FAA are addressed. So that kind of rounds out, I think, a bit of this first cut that we're taking at Enterprise Traffic Control. What we're going to do is continue to cut through these layers and add more and more detail and dig into all these topics. In the very near future, we're going to try and process individual department workflows through this to get down to the sensors and kind of how this might work in a particular environment. So I want to thank everyone for joining us today. Exciting discussion. Starting out, these things are going to be a bit abstract, kind of as a reminder. The abstraction is intentional. It allows us to be able to create those layers that are going to be necessary for things like ontology and AI and the kind of things that we want to do in the future. But hopefully, even with the abstraction, this becomes very informative, and it starts to paint a picture of what enterprise traffic control might look like. So thank you.